Kia ora koutou. My name's Bruce Warburton, and I have the pleasure of hosting this Biosecurity Bonanza webinar this afternoon. I'd like to extend a warm welcome to you all and thank you for joining us today. Our presenter today is Dr. Graham Hickling, who is a principal researcher with the Bioeconomy Science Institute. Graham has several decades of research experience looking at a range of pest species, their biology and behaviour, wildlife disease, and control strategies and tools. In this seminar, Graham is presenting some work on removing the last 1% of mainland predators, essentially trying to make the unwilling willing. As with all our webinars, we encourage you to add questions via the Q&A function, and at the end of the presentation, we will try and answer as many as we can in the time available. Both the presentation and the Q&A session will be recorded. So I'll now hand over to Graham. Thanks, Graham.
Thanks, Bruce. Kia ora koutou. So thanks for the opportunity to tell you today about our recent project tackling the challenge of predator-free management on New Zealand mainland. So what I'll talk about today, firstly, introduction in terms of what we mean by this last 1% of a population. And I'll illustrate that with a quick case study of some possum trapping that we were involved in up in North Canterbury. Then I'll tell you about the smart idea that we tested. And the reason we're calling it a smart idea is that's literally the funding program that funded the research, the MBIE Smart Idea program. I'll tell you what we found, and I'll tell you where to next from those results. So the problem that we're addressing is that conventional pest control methods like trapping and shooting leave behind some survivors, leave behind trap-shy individuals, bait-shy individuals. And for the last 5 years, our research has kind of focused on those survivors through the eradication science program. So the problem, conventional methods leave behind bait and shy, trap-shy individuals. We've been focused for the last several years through an eradication science funding program on those survivors. This smart idea was kind of an add-on, a smaller subset of that broader program. And so the example I want to give you is a small North Canterbury reserve, lottery bush up north of the Waia River. It's about 120 hectares. And back in 2021, there was a community group was setting up to try and eradicate the possums out of that block. And we stepped in and essentially helped them establish quite a substantial network of about 140 traps in that area. Various different trap designs, but the majority of them are what we call head-in traps. So this is a sentinel. There were also trapinators, which are of similar design. And these are traps that require the animal to come right up and put its head into the opening to trigger the trap. So this is kind of a development from in past decades. There was a lot of ground-based leg hold trapping. These head-killed traps are considered to be more, a bit more humane, ethical, and also they're protective of ground-dwelling birds in areas where that's a problem. However, there are possums that are very reluctant to do what we just talked about. They're very reluctant to put their head into a trap like that. I was telling you about our possum control in Lottery Bush. We ran it for 7 months with this network of kill traps. And essentially what we got after 7 months was a very rapid decline in trap catch. So that's the left-hand graph. You can see possums per 100 trap nights falls to near zero. And on the right-hand side, the effort it took to catch those remaining possums just skyrocketed. So towards the end, it was taking 800 trap nights per possum that we were caught. Everything working okay?
Yep.
All good. Got it sorted. Okay. Thank you.
So as control work progressed, as I said, trapping dropped to zero, but there were still possums in the area. We had cameras out, and so we were seeing that there were possums in there that we couldn't catch. And so here's some examples of possums. Hopefully. this is what we were seeing on the cameras towards the end of that trapping program. And I'll just, a spoiler alert, in this show, there are not any possums getting caught in traps. I figured you wouldn't want to see that over your lunchtime. So here's the problem. Possums that will do everything, they'll crawl and sniff and clamber, except actually put their head in the trap. So we estimated we got about 95% of the population in that lottery bush program. The question then is there a novel way that we could target those last 5% that were essentially untrappable? And the smart idea arose from previous observations that said that even when you have bait shy and trap shy predators in an area, they are willing to still cautiously sample baits as long as they're accessible. So they won't put their head in a bait feeder, they won't put their head into a kill trap, but if you leave bait out in the open, they will at least nibble on them. And so that suggested the idea, well, maybe if you give them something really good in those baits, that would incentivize them, generate reward-seeking behavior, and overcome their previous reluctance. And so specifically, we tested the idea that putting a central nervous system stimulant, a pharmaceutical drug, into the bait might be a way to overcome trap shyness. Just a really quick background to the drug link. Reward-seeking behaviors in mammals is triggered by dopamine release. Chemicals as simple as sugar cause dopamine, but there are kind of super sugars out there, things like the amphetamine group that increase dopamine. And actually, the increase in that particular compound is caused by, rather than releasing more dopamine, it stops dopamine reabsorption. So it's working on a slightly different mechanism, but the same kind of idea as really palatable foods like sugars and fats, but amped up a notch. So we tested 3 pharmaceutical compounds for a proof of concept. Now, obviously, in the real world, we would not be advocating this kind of thing as a practical control measure. So the idea was a proof of concept using a potent compound. And then if that worked, we would go back and look for more kind of pedestrian compounds that sit somewhere between a sugar and an amphetamine as something that might actually be field deployable. But first off, we wanted to see if we could get the method working. So we tested 3 compounds, dexamphetamine, varenicline, and oxycodone. Dexamphetamine is an ADHD medication, varenicline is an anti-smoking medication, and oxycodone is pain relief, but all of them have an effect on the dopamine release system, and so also have behavioral and, if misused, addictive effects. So we dosed possums and rats in captivity with these drugs, and we needed a way to score whether we did achieve increased reward seeking. And in the clinical literature, there's lots of methods that psychologists use for this, but we wanted to keep it real, keep it targeted on the behavior that we particularly wanted to incentivize, which is animals putting their heads into devices. So for rats, we just created a simple PVC tube device. We would pre-feed the animals for several days. Then we would put pellets in these tubes for a couple of nights and see if they would retrieve them. Pretty simple chore. They could reach them easily enough. It's just whether they wanted to. If a rat did achieve that task, we escalated things a bit the next night by taping over the tube to see if they would actually break through to get the pellet. And so here's an example of a rat on its second night. There's pellets inside that tube, and it's going to have a go at getting them out. Now, this rat actually took several minutes to do that. So in the interest of time, I've sped this middle bit up. So you'll see him working away, and in a second, I'll slow down back to normal speed. And you see he reaches in, grabs the pellet, heads off to his nest box. So that was the rat strategy. For possums, this was done in outdoor pens. Here we substituted the tubes for a deactivated head-in trap. This is a Tim's trap. We put one pellet on the ground inside, which was pretty accessible. Another pellet was raised up on a ledge, which made it a bit more challenging to get to. So here's a possum, and possums are pretty strong. So really the the tape is much more of a psychological barrier than actually a physical barrier. You'll see in a second that he has no problem at all getting into the trap. So that's the kind of behaviors that we observed. We had 3 drugs and we had several different doses of each of them. And so each combination was tested in a 10-night trial. For 3 nights, we put the treated baits out just in the open pen where they were easy to get to. Then for 2 nights, they went into a device, either the tubes or the Tim's trap, for 2 nights, and then we repeated that on a second cycle. And at the end of those 10 nights, we took the data from the behaviors we saw on the 4 device nights and boiled those down into a score, which ranged from 0, where no pellets were taken on any night, through to 10, where every pellet was taken every night, including breaking into the tape to get at it. What we were aiming for was a score that basically the average animal would sit about the middle. There would be some that were bolder and more driven, and there'd be some that were much more reluctant to do much of anything. So what we were looking for was a bait that met 3 criteria. Firstly, it had to be stable when you put it into a cereal bait, have a decent shelf life, and so on. It had to be palatable, and we tested that relative to the standard RS5 pellets that are used for general pest control today. And then, of course, the important one is, could we demonstrate increased reward-seeking behavior within that 10-day trial period? So the first couple of criteria are easy to answer. Yes, all these compounds were stable and persisted in cereal baits. They didn't break down. The Dex and the Oxy were palatable. So they were just, the animals were perfectly fine eating those baits. They didn't avoid them at all relative to untreated bait. Bit of a different story with the varenicline. That was less palatable. Animals only ate about half as much. Now, depending on the behavioural effect, half might have been enough, but it was a bit of a warning flag about that particular bait. And then, of course, the critical question is, did we see increased reward seeking? So we did a lot of trials. We had 3 baits. We had 2 to 3 doses, 3 drugs, 2 to 3 doses of each one. But to be honest, the overall outcome was similar for all of those treatments. So what I'm going to show you now is essentially all of the non-treatment group rats that we had as a comparison aggregated together, and then all of the treated rats with the 3 different doses added together. So here's the untreated rats, the experimental controls. And what you can see is that there was a wide spectrum of reaction to those pellet challenges. We only had a couple of rats that are down the right-hand end that took all the pellets all the time. And in fact, the most common category were rats that didn't take any of them ever. So over a third of the rats in a pen with the tube open right in front of them, easy to reach, easy to see the baits, did not do that. So we have this wide spectrum of behavior. And what we were hoping is that with the pharmaceutical treatments, we would shove that distribution to the right, that would see more of them up in the high reward seeking index. And here's the result, the exact opposite. We saw reduced reward seeking with all 3 treatments. So that is pretty disappointing and also kind of unexpected. And I don't have a solid explanation for why we got that result. One possibility is that the dose wasn't ideal, but we did test a range of doses. With the dexamphetamine, the highest dose, we had some behavioral signals that it was probably a bit too high. So we feel like we didn't underdose, that we were in the correct range. The 10-day trial may not have been long enough, and I think that is a big part of the explanation. But we were looking for something that would be practical to do in the field. And our feeling was that if it takes more than 10 days of pre-feeding with any of these methods, it's really not going to be practical or affordable or feasible as a field approach. Maybe in some specialized situations, but not for kind of standard control. An important point to recognize is these were captive animals that had freely available maintenance food. So that's quite a different situation from a wild population that may be under more food stress. And similarly, these are animals being tested in isolation in individual pens. And we know from other work we've done that feeding behavior is a very social process, that possums and rats, watch each other, they take cues from each other. So there's really some limitations, I think, in testing a question like this in captivity. So where to next is field studies. And obviously we've got a problem in getting approval and social license to do this kind of thing with pharmaceutical compounds in the field, particularly when we didn't have a proof of concept from the captive studies that this would be a good thing to do. So the approach that we've taken is kind of take a step back to the fact that sugars and fats do operate on the dopamine cycle. And so the possibility here is that we could use a high sugar, high fat pre-feed as a kind of a surrogate for the stimulants that we had been testing in captivity. And there's a precedent for this in the psychological clinical literature. There's a paper here talking about co-sensitivity to both palatable food and cocaine in rats. What's the implications for addiction? And a quote out of there is, there's direct evidence that foods rich in sugars and fats can engender addictive-like processes. And the incentive food they used in that study was Oreo cookies. And so as it happens, if you go down to, New World or Fresh Choice or whatever at the moment, Selena Gomez Oreo cookies are on sale. And interestingly, that particular flavor brand is cinnamon and chocolate. And so those of you that have done possum rat trapping know that cinnamon's a highly preferred lure for possums. Rats really like chocolate. So we've just made an early start on some field trials using pre-feeding with Oreos. And so what we've been doing is setting up a couple of Oreos attached to the access plank for a head-in kill trap. And then we've put an Oreo in the back of the trap. So for the animal to be able to get to that, it would have to trigger the trap mechanism. And we've been working down in a small bush patch near Leaston. It's about half a hectare in size. What we did was we put out 2 kill traps. For the first 9 days, we just ran them as usual. And then for the next 21 days, we implemented the pre-feeding regime with the Oreos on the plank, like I just showed you. And the day that I was out there, day 1, setting up the traps with my technician, Becky, I said, I think we're going to get a couple in that first period. We're going to get a couple more in the pre-feeding, and there'll probably be a couple left at the end. But let's see how we go. So the first 9 days, we caught 1. Then the pre-feeding and the plank went out. The Oreos and the plank went out. And here's what happened. So about 20 days in, the catch started tailing off. And by day 30, we had cameras out, so we knew sort of who was still out there and not being caught. There was only 1 survivor at that point. And the interesting thing was that survivor still visited. It still ate the Oreos off the plank, just would not put its head up in the kill trap. And so on day 31, we changed strategy a bit and we added a different kind of trap. This is a Connor bear, one that is a much more open design, doesn't need its head, a head in to an enclosed space. And 2 nights later, we caught that final possum. So I better wrap up because we're pushing time, but the conclusions, thinking back to Lottery Bush, these kind of kill trap networks can achieve very high kills if they're intensive layout of traps and they run for a number of months. The work, despite the kind of discouraging pen trials, the last bit I talked about does suggest that pre-feeding, particularly with high reward pre-feeding, can be used to incentivize some of those trap shy animals that are left behind. But even so, I think the last 1%, which was the title of this talk, are probably going to avoid head-in traps regardless of what pre-feeding we do. So there's still a challenge there. And the final point to make is, it's a difficult topic to target these survivor individuals. There's kind of a paradox that you can't really study untrappable animals in captivity because you can't catch them. And in the field, the problem is separating out a genuine survivor that's been there all along from an animal that's a new immigrant that may be perfectly trappable but has only just arrived. And again, in a lot of wildlife studies, you would tag animals, but to tag them, you have to catch them. So this is sort of the challenge of where to next that we're mulling how to get to. So I will stop. I really apologize for the disruption at the start, but hopefully there's a little bit of time for questions. Just really quick acknowledgements. Bruce had the original smart idea. Kyla Johnson led the lottery bush study. Elsa and Bruce McGregor at University of Otago provided all our pharmacology advice. Emily and Lee ran the animal husbandry and the behaviour trials, and we really appreciate the smart idea funding that came from MBIE. Oops, thank you very much.
Thanks, Graham. Yeah, thanks for an interesting presentation and for dealing with those gremlins in the system. Adrian, I can't see any questions, so I'm guessing there's none at the moment.
We just have one in the chat area.
So yeah, so Graham, this was always going to be a hard nut to crack. If you increase the sort of willingness of target species to enter a trap or eat a bait, will this also affect non-targets?
Yeah, I mean, that would be kind of the next step. If we had got a strongly beneficial effect from this approach, there's a really quite a long process between that proof of concept and anything that would be operational. Non-target species impacts would be one of the key ones to look at.
Cool. And Jason asks, what about the use of poison baits and the high reward foods? And also, has there been any work looking into controlled release of biocontrols? I'm not quite sure what he's asking. But
so the focus of the talk today, just because of the interest of time, was all about trapping. But I think the same argument would apply to toxic baits, that if you could do a non-toxic pre-feed, I mean, we already do that in many operations for a couple of nights, but maybe an extended non-toxic pre-feeding with high reward pre-feed, and at the end you swap to toxic baits. That might well be a strategy. It just, the extra pre-feeding adds cost. It's something you would probably do at the end of a conventional control operation to try and mop up the last survivors. The biocontrol one I'll leave. I mean, there are groups that have been investigating that for many years. It's not, I don't think it would even really be on the horizon right now, but it's certainly being considered.
Right, thanks. Kate asks, were the Oreos just on the runner board or in behind the trap as well?
Both. So there was one halfway up the plank, one at the top of the plank, and one at the back of the trap. And so that final possum that we weren't able to catch would still take the ones off the plank, but each day when we went out there, the one at the back was still intact.
Cool, thanks. I have a question. If trapping is leaving 1% that are reluctant, is that behaviour, personality, or whatever, is that likely to be transferred to their offspring? Is it genetically linked? And do we know?
Well, I think my understanding from comments Patrick Garvey's made is that those kinds of behaviours are about perhaps 50% genetic. So I think there would be potentially strong selection for animals that are at the more reluctant end of the spectrum. I think there's also a behavioural component. And so if you had traps where you were getting escapes, that could be generating additional caution in some animals. So I think trap shyness is a mixture of the two things.
Yep. Okay, thanks. And Fernando is asking, have you done any similar trials with feral cats?
I have not. I mean, there have been baiting trials done with cats. Some of those would have involved pre-feeding. I talked about high fat, high sugar. For predators, one of the go-to baits is either Kentucky Fried Chicken or McDonald's, and that's probably leveraging the fat rather than the sugar. But in terms of trials, it's not something that we've done ourselves.
Right. Thank you. Why don't there's a new question coming through. Chris, what about nicotine and caffeine as addictive compounds?
Yeah. So early on, we had a lot of discussion about which compounds to test, since we had sort of limited ability, and nicotine is probably going to be relatively unpalatable in a cereal bait, and is also quite toxic if you get the dose wrong, both for the people handling the baits. Sorry, it was nicotine, and what was the other one?
Caffeine.
And I think, I mean, we were going for things that were quite potently semi-addictive, and I think caffeine, I would expect you would need a longer period of dosing to start getting that effect. There are many compounds out there. We had to have a short list. So that would be my answer to that.
Cool. We'll just do these last two questions and then I'll close. Have you tested using Oreos and rat traps?
No. So that would be, depending on funding, that would actually be really interesting to do, because I think the problem of getting rats into traps is more severe than the problem of getting possums in. There are species that's kind of evolved around humans, and they are particularly wary. And you saw that in that, more than a third of the animals wouldn't even go into the simplest of challenges. So I would like to do that next.
Yeah. Okay. And last question is just a clarification from Jason again. He was thinking more mixing the toxic bait into the high reward foods. That way you could encourage the uptake of bait and potentially bait shy individuals.
The risk of putting the toxin in early on when they are cautious and only nibbling is that they don't take a lethal dose, and that animals, in terms of diet, are pretty quick to develop bait shyness if they get sick from something they've eaten. If the idea was to go for a number of days with pre-feeding without toxin and then add toxic to that same bait, I think that's a good idea. And that's kind of what we do already with the RS5, but that's just kind of a couple of days of pre-feeding, not a more extended period. And that was really the motivation of the original study. Is there something that we could add that was a bit more, that was kind of like an escalated version of the molasses that already goes into RS5. So that is kind of the concept we were looking at on the baiting side rather than the trapping side.
Thanks, Graham. So thanks again, Graham, for sharing your research today and dealing with that glitch. And I'm on behalf of the Bioeconomy Science Institute team, thank you all again for joining us today. Ka kite anō.
Thanks, everybody.